is a Glasgow-based firm, and we're a manufacturer of large heat pumps. And I know there's always been some tension between heat pumps and district heating, but I hope tomorrow in the presentation I'm giving at 9 o'clock, so I'm not going to have too much biscuit tonight. I hope in the presentation at 9 o'clock to be able to convince you that actually large heat pumps and district heating are actually good friends. And so that's the part for tomorrow. You probably noticed that it rains from time to time in Glasgow, and historically we've always done something very useful with the rain in Scotland. You think we just endure it because we're really tough. Actually, we make it into whiskey. So we're going to hear a little bit about the expertise of whiskey from Chris White. Well, I was going to say that the first heat pump I got involved in was for Fortum, which is a nice coincidence, but actually the first one was a chocolate factory in England, and that sounds much more fun than district heating, I have to admit. But this presentation is more about district energy, district heating. We're at a watershed moment, pardon the pun talking about water, a watershed moment, but we are seeing a colossal change in the external factors to your businesses. So you can make decisions based on what you think are solid facts, and then the solid facts change. And that's a really difficult thing for any business to cope with. The thing that's really changing is the focus on carbon. So yes, it's all about the cost to the consumer, and lowest cost gets consumers to connect, which is good. But fundamentally, our leaders in Scotland, in the UK, in Europe, around the world are focused on a carbon challenge. And so if at the moment there isn't yet enough pressure from a carbon perspective, you can pretty much guarantee that it will happen. Otherwise, collectively, we fail. So this is a story of where we've been. This is a screenshot from the stand that we've got outside. And if there's any more detailed questions, come and see me afterwards. But it's a quick stroll through the observation of district heating and heat pumps. So starting with that policy thing, the Paris Agreement is really very simple. It basically says by 2050, we have to be using 80% less fossil fuel, or creating 80% less carbon emissions. There are some discussions about clean fossil fuel, but I think it's fair to say that we have to see a massive shift in what we're doing. We've also got increasing challenges with air quality. London is permitted under EU law to have 16 air quality exceedance events in 1 year. It managed to achieve this on the 9th of January last year. I thought that was impressive, to achieve your year's targets in only 9 days. They managed to do it on the 5th of January this year. Air quality is a colossal problem, and yes, it's largely due to vehicles and diesels, but significantly also from the combustion of fuels. And I think if we're doing activities that undermine those moves, that's probably going to receive focus. And certainly in London, it's much harder to implement certain technologies now because of air quality reasons. So back to the policy piece. This is a graph from the Climate Action Network. And basically it shows that at 2010 they predicted what the current policy would achieve by 2050, and it's not good enough. So if you're feeling under pressure in your business that carbon is going to become more of a focus, then that pressure is going to have to be cranked up, because we're going to miss the targets of an 80% reduction. So a short warning, if you like. I mentioned the grid decarbonising. I checked in my phone, I've got an app this morning. The UK grid at the moment is at 206 grams of CO2 equivalent per kilowatt hour of electricity generated. That has dropped from around about 550 in only 4 or 5 years. So basically what we're seeing is all these technologies, the horizontal blue line at the top is a gas boiler, so clearly the electricity grid doesn't influence the gas. The red line sloping from the bottom right upwards to the top left is gas CHP. That is increasing in its carbon footprint as the grid decarbonises. Heat pumps, the green line is decarbonising as the grid decarbonises. So without doing anything, anybody that adopted one of these technologies is seeing their business change under their feet. So right now, we're at 200 grams, which is about there, if you have a heat pump doing heat only, or are way up here if it's gas CHP. Now clearly that grid intensity varies during the year, but I haven't, in the space of this year, in the last 6 months I've been checking, seen much above 350. So even at 350, we're seeing that we're on a move. And I think that the lesson from this is, you can't be absolutely certain of the facts, but you can probably predict the direction of change. We're not likely to see the grid start to recarbonize. Otherwise, we really have failed in our target. So we have to expect the x-axis to be moving from right to left. So, what does this all mean for Glasgow and why are we interested? Well, we're a manufacturer of large heat pumps. Industrial refrigeration was our core. And this all stems back to 1852, a lecture Lord Kelvin gave in Glasgow about heat engines. And he was talking about the genesis of refrigeration and also heat pumps. Refrigeration clearly took off. Prior to this, countries around the world were importing ice from foreign countries. So even from Bombay, they were achieving deliveries of ice from North America, from the Boston area. Refrigeration took off because it was an obvious thing to do. Heat pumps really haven't. You know, over the years, there's not been very much uptake at all, simply because it's not the easiest way of doing something. As we look at big heat loads, this is Glasgow University. The river next to Glasgow University has a significant quantity of heat that could be harvested for the university. So how did we get into this? I mentioned about Drammen in Norway. Back in 2009, I first visited, and we were asked, could you do an ammonia heat pump to achieve 90 degrees for our district heating? It had never been done before, but we did have a history in high pressure working fluids. We did have a history in low charge working fluids and high efficiency. And we were as surprised as a consortium which was half owned by the city of Drammen and half owned by Fortum, that when we crunched the numbers, an ammonia heat pump used 25% less electricity than an HFC heat pump. They also had the kind situation where the carbon emissions from leaking working fluids were much lower. And it's round about 1% per annum from a heat pump, which is round about 800,000 kilometres of driving equivalent, had this been R134A. So that was a massive piece for the city. So it was built, they're very proud of it, it's in a glass-fronted building, and they're now getting round about 14 megawatts of heat at 90 degrees from seawater. So the seawater is only about 4 degrees after we finish cooling it. We cool it from 8 down to 4, and that's pretty much all year round they can achieve that. Obviously the heat demand varies. They go from about 2 megawatts in summer, up to around about 14 megawatts in spring and autumn, and in the heavy winter months they bring gas in on top of that. The significant thing though is, because the heat pump's a very flexible device, they're actually getting about 85% of the heat from this energy centre from the heat pump and only 15% from the top-up gas. So we might well have to keep using fossil fuels of some sort, but at least it's only going to be a small component. We played a couple of tricks with this that are worth mentioning. We actually have 3 heat pumps in series. One is heating to 90, one is heating to 80, and one is heating to 70. We also have 3 heat exchangers for the seawater, which are titanium and tube design. So it's very easy to clean them, and they're able to give us a very high performance with a very, very low charge of working fluid. Not the best photograph, but the point of this one is we're actually even recovering the waste heat from the electric motors, which is around about 3%, and we feed it back into the system. So you will have heard the stereotype of the Scots being very tight. We're also very tight with kilowatt hours as well as pounds. And this is the good number for us. We're getting an efficiency, what we call a coefficient of performance of over 3. So for every 1 unit of electricity that we consume, we're getting 3 units of heat. And that's quite a significant ratio, far higher than they were expecting. So there it is there, a couple of headline aspects for it. I mentioned about the economics. This site, when they burn gas, costs about 50 euros per megawatt hour. Electricity for this site costs about 30 euros per megawatt hour. We're getting 3 units of heat for that. So heat costs 10 euros per megawatt hour from the heat pump, or 50 from the gas boilers. You can imagine which one they want to run the most. It's 100% cleaner because they're not producing any emissions on the site. Entirely through the project, we've been saying to them, try and find some cooling opportunities. We're actually throwing away 10 megawatts of cooling back into the fjord. That's enough for 10 football stadium-sized data centres. That's a massive sales opportunity. It's probably at around about 30 euros per megawatt hour of cooling. It would be round about 2.4 million euros per year. So that's a significant opportunity to improve the economics. As I mentioned, 25% less than HFCs and 100% less global warming. And this is a significant challenge for the industry. We mustn't jump from burning fossil fuels to using heat pumps that have a high global warming potential from the gas. That would plainly just not be a good idea. And I mentioned about 800,000 kilometres per year. So a couple of things we learned during the piece of this, that actually the capital cost for heat pumps is very low. It's only about 15% of the life cycle cost. Maintenance makes up a significant piece, but it's actually the electricity. So if you're investing in any heat pumps, the key thing to focus on is the efficiency, the operating cost. We also learned from the client about something that we hadn't really experienced before, because most of our cooling customers had an absolute need to have cooling. So return on investment wasn't really something that crept into the industrial refrigeration piece. But they taught us about having to have a heat source. In our case, we're very focused on using rivers and the sea because they're very prevalent around our countries. You have to have the heat demand, and that was evidenced by the previous speakers about finding different clusters of heat to add onto the system. Equipment capability is very important, but what was incredibly impressive was that the consortium had this end-user vision to drive forwards in their technology. They could quite easily have just kept burning gas for their district heating, but they wanted to move forwards to a cleaner and more cost-effective solution, and absolutely driven by return on investment. So, what could we do for Glasgow? As I mentioned, this is a watershed moment. Since 2010, when Drammen was commissioned, I honestly thought that heat pumps would be flying out the door and we'd do loads around the UK. We've got an incredibly valuable support for this in the Renewable Heat Incentive, which basically paying the customers a subsidy not to burn gas or create carbon emissions. And yet the market has been incredibly slow. I think part of that is because of the low gas price that we've experienced over the last 7 or 8 years, but also we've seen a tremendous uplift in biomass, for example, and gas CHP has been very popular. But thinking about Glasgow and what we can do with this, there's 8 times as much heat in the river that you see as you walk out this exhibition centre as the entire city centre needs. So it's an untapped resource that Mother Nature just keeps bringing to us. The sun shines in the valley, further upstream. Gravity brings the water down towards the centre of the city. So it's a free distribution into the place where we have the maximum heat density. If I've learned anything about district heating over the last few years, it's you want the maximum number of kilowatt hours for the minimum number of meters of pipe. And I think the previous speakers were getting a lot more scientific about that. But my simple brain puts it down to kilowatt hours over meters. And so the river is bringing this right into the centre of where our heat demand is. So I'd like you to ponder as you walk away from this event about what could happen in your city. Even if you don't have a river in your city, absolutely certainty there's going to be a large sewage treatment system. There's going to be water being dispersed into somewhere. And we've seen this around some of the colder countries. Very impressive project in Finland, in Turku, which is harvesting the wastewater at the end of the wastewater treatment process. So there are water resources all around the place. They're very easy to get a hold of. With the right engineering, you can really do something quite easily. The UK, rivers absolutely everywhere. I'm sorry that you experienced some heavy rain yesterday, but that's just a fact of life in most of the countries that there's rainfall. The government did a good thing in heat mapping, and I've seen some incredible science. They basically mapped the heat demand in the UK versus the river resource. So the red areas you see in the map are the coincidence of heat demand and water resource, surface water resource. And there's very few places. I think Birmingham is probably the only place. The assessment didn't really take into account wastewater treatment plants. So I think anywhere you can see that there's significant quantities of water resource. So I'll leave you with this final graph, which I showed at the beginning, just to say, do think about the way that the external environment is shifting. If you believe that the grid is decarbonising, which has significant impacts on the cost of electricity as well, then I think you generally want to see a move towards renewable heat because it's likely to be a lower cost option for you. And I think that's about it, other than my email address. Be delighted to hear from you or come and see me in the stand. And also the slides are available at tinyurl.com/LCITP-Gorbals. Thank you.